All right, the big idea, equivalent ratios, but there's a little bit of a curveball to this one. We'll get to that in a moment. The strategy, we're going to create a table. Here I've got a table, and we're going to incorporate drawing a picture in there as well, and I'll show you why. The picture is going to help us understand that curveball. Okay, we know that 3/4 of the children are girls. The question is, if there are 60 girls, then how many boys are there? So if we know that 3/4 of the children are girls, here's what we know. For our table, we're talking about how many girls are there. So from this given information, what number should go for girls? 3 girls. 3 girls out of how many total kids? 3 girls out of 4 total kids. Here's the trick on this one. Eventually we want to get to 60 girls, so eventually we want this number to get up to 60. But one thing we're missing in this table is it doesn't tell us how many boys there are. And the question specifically is, if there are 60 girls, how many boys are there? So really what I'd like to do for this table is create another column that shows the number of boys. Now, how many boys are there? Is it three boys or 4 boys? Turns out they didn't tell us how many boys there are. So here's where the picture might help just to kind of understand what they're telling us. I'm going to draw a picture that shows 3/4 of the children are girls. So I'm going to draw 3 girls. I'll give them longer hair to represent that they're girls. And we're going to need a boy here. The boy has a face, the girls don't apparently. But okay, so this picture right here shows that 3/4 of the children are girls. We've got 3 girls and 1 boy, meaning 3/4 are girls. So now this picture kind of shows me, oh, there's 1 boy. And the reason the picture helps is because a lot of people might make the mistake of putting the 4 under the boys column. They might think 3 boys and 4 girls. But this picture shows us that there are not 4 boys. There are 4 total children, and 3/4 of them are girls. So 3 girls, 1 boy, equaling 4 total children. So again, the picture helps you understand what numbers get assigned to what values. Is the 4 the girls? Is the 4 the boys? Is the 4 the total children? That sort of thing. Now that we have all the numbers assigned the correct way, now we can scale up or we can scale down. Let's say we doubled this to 6. Then what would these numbers be? Well, if there are 6 girls, that means there would be 2 boys and there would be 8 total children. Now, if I was going to continue the pattern, it would go 3, 6, 9. This would go 1, 2, 3. This would go 4, 8, 12. Like that. And I could continue this pattern as much as I want. I could go 3, 6, 9, 12. This increases by 3 every single time. Every time this goes up by 3, this goes up by 1, so it'd be 4 boys. And every time this goes up by 1, this goes up by 4, so it would be 16 total children. But I really want to go until this number is 60. So I'm looking for a shortcut. I could go all the way until I get to 60, but looking for a shortcut. Now the shortcut could be, can you multiply that to equal 60? If you do, you can multiply this by the same thing and that by the same thing. Turns out you can multiply 3 to get 60. You could also multiply 6 to get 60, or 12. 9 gets a little tricky. I'm going to take the 6. I'm going to take the 6 and multiply it to make it 60. Now, if the 6 changed to a 60, think about what this 2 would change into right there, and think about what this 8 would change to right there. So the rule is, if I multiply this by 10, I need to multiply this by 10, that equals 20, and I need to multiply this by 10, that equals 80. Just as a double check, if there are 60 girls and 20 boys, does that add up to 80 total children? And it does, because it's exactly right. It's exactly how the table is supposed to work for us. So the answer to the question is, there should be 20 boys. There you go. All right, so that's doing it with the table. Let's say I wanted to use equivalent ratios written as a fraction instead of a table. So I want it to be, if there are 60 girls, then how many boys would there be? All right, see if you think this will work. 3 out of 4 equals 60 out of how many? Is this table set up the right way? not table, is this equivalent ratio set up the right way, or is there a mistake in there? So this is 3 girls. Think about what this 4 represents, because if it's girls in the numerator, boys in the denominator, this is supposed to be girls, this is supposed to be boys. Now here's the curveball. If I thought this was right, here's how it'd work. 3 times 20 is 60, so 4 times 20 is 80, but 80 is not the right answer. So what happened wrong? What happened wrong is this 4 was not boys, so it's not going to lead us to how many boys there are. So it should not have been 3 over 4, even though 3 over 4 was the given information. This is where this picture comes in to help us. In this picture, it shows that there are 3 girls, but there's only 1 boy. This should be a 1. And now, 3 times 20 equals 60 girls, 1 times 20 equals 20 boys. This is how you want to have it set up. So again, if you use the 3 over 4 in this equivalent ratio, it's going to lead you to the wrong answer. So you have to make sure that you, in the equivalent ratios, have the right numbers. The picture helps understand that 4 is not the right number for how many boys there are. 1 is the right number for how many boys there are. So again, it's equivalent ratios, it's making a table, but it's got a little bit of a curveball. You have to make sure that you really understand that you have the right numbers for the right things. The picture helps with that.